All right, today we're going to be talking about compound events. In the last lesson, 127, we talked about single events happening and the probability of that calculated in three different forms. So today we're going to look at what happens when we combine different events to figure out the probability. So first we're going to look into a skill, just to practice a skill. We have Eustace who's adding fractions. So we're on page 2 of our toolkit. Here's his work. 1/2 plus 2/4 equals 3/6. So let's go ahead and set up our paper. So this is page 2, lesson 128, and the question in our book is 130. So here's Eustace's work. Go ahead and copy that down. And our question is, does this make sense? Or is this correct? And we can see, first of all, we see how he got his answer. 1 plus 2 is 3, and 2 plus 4 is 6. But is this the correct method? Okay, so the method is actually incorrect, because we all know that when we add fractions, they need to have the same denominator. So let's work this out correctly. What would that first fraction and second fraction need to need to change to? So first we look for a common denominator. Alright, and that common denominator is, in this case, 4. And the reason being, the two denominators both have 4 as a multiple. So the least common denominator is kind of the same as the least common multiple. So what we need to do now is change those fractions so that they both have a denominator of 4. So let's start with 1/2. So 1/2, if we're going to change those to fourths, that means we'll need a giant 1. And in that giant 1, we are going to be multiplying by 2 over 2. And so this makes this equivalent fraction 2/4. Okay, and then this fraction right here is already 2/4. So that means we now have a new problem. We have 2/4 plus 2/4. And in this case, we get 4/4, which is equal to 1. So just remember this as a necessity whenever we're adding fractions, that they do need to have a common denominator. So moving on to the next problem. Lindsay has a paper bag full of Fruity Tooty Chews in different fruit flavors. She says if you reach into the bag, you have 1/3 chance of pulling out Killer Kiwi, and there's a 3/5 chance that you get Crazy Coconut. So we want to find out first is, what is the probability of getting coconut or kiwi? All right, so let's look at these and work them out. So this is number 131 in the book. We have the probability of pulling out a kiwi is 1/3, and the probability of getting coconut, we'll just put cocoa, is 3/5. And we need to know what is the probability of kiwi or coconut. Okay, and what we learned in a previous lesson is whenever we see this word in a combined probability problem, that means that we are trying to find the sum of those two probabilities, right? The probability of kiwi or coconut means what is the sum So that means we are taking the probability of kiwi and we are adding it to the probability of coconut, right? And this will be the probability of kiwi or coconut. All right, I'm shortening it a little bit more. So let's go ahead and work that out. So we know first the probability of kiwi is 1/3, and the probability of coconut is 3/5. And so we are now adding fractions, but now we're adding fractions that don't have the same denominator. So let's go ahead and do this. 1/3 plus 3/5, and I find whenever we're using the giant 1, it's easiest to lay them out vertically. So then we can just put our giant 1s here. So we're multiplying by something. And what is going to be our common denominator? All right, and we know the common denominator is 15. So what am I going to multiply both of these fractions by to get a denominator of 15? All right, so you should have answered. I'm going to multiply this by 5/5 because 3 times 5 is 15, and then I'm going to multiply this one by 3/3. That's my giant 1 for this one. 5 times 3 is 15. So that gives me my numerators. If I go across, 1 times 5 is 5, 3 times 3 is 9. So now I'm adding 5/15 plus 9/15, which will give me 14/15. Right? So that means that 14/15 is the probability of kiwi or coconut. 14/15. Okay, and the next question is asking, do we know that there's another flavor? Is there another flavor in here? Is there another flavor? Okay, and if so, how do we know? So think about that for a while, and what do you think? So if you notice, there's 14/15, so that means if we're thinking about this as a whole, 15/15, we're missing a piece, right? So we're missing 1/15. So is there another flavor? There is another flavor, and what would be the probability of getting that other flavor in this bag? All right, so the probability of another flavor is, hopefully you guessed, 1/15. Or you calculated 1/15. That is the probability of getting a different flavor. Okay, so the next question is, do we know how many candies are in the bag? Do we know how many candies are in this bag? All right, so some of you may guess, yeah, we have 15 candies in this bag, and 14 of them are kiwi and coconut, or kiwi or coconut, and one of them is something else, say a tasty tangerine or scrumptious strawberry. So one is the other. Okay, so we know that there could be 15 in this bag. Can there be more than 15? And let's think about that. Now, you might have guessed, well, if the probability of getting another color, another flavor, is 1 out of 15, I can do this. I can say, well, the probability of getting another flavor is equal to 1/15, but can be a different fraction. So let's think of a different fraction that's equal to 1/15. Okay, so if you guessed 2/30, then That's also equal to 1/15. What's another fraction that's equal to 1/15? So if we use a giant one of 3 and 3, we have 3 out of 45. Or if we multiply by 4, we get 4 out of 60. So since all of these are the probability of getting something else, the probability is still 1/15. So is there 15 candies? Are there 15 candies in the bag? And the answer is no. There's not just one other flavor. There can be 2 other flavors, because the probability of getting those other flavor is 1/15. There can be scrumptious strawberry and tasty tangerine. Can there be more than 2 flavors? Yes. If there's 45 candies in the bag, there is possibly 3 other flavors. Bodacious banana. And then if we have 60 candies in the bag, there could be possibly 4 other flavors. Right? And that would be awesome apricot added to that. Right? So there could be many. So there could be 45, there could be 60, there could be many others. So is there another flavor? Yes, but also there could be many others. There could be many other flavors. All right, so let's move on to the next question. So Lyle is asking his teacher to give him a challenge problem. And here's what his teacher said. There's 2/7 chance of getting a red marble out of a bag of marbles. And if the probability of getting a red or a blue marble is 2/3, what's the probability of drawing a blue marble? Okay, so this one is kind of challenging. So let's go ahead and investigate that. So we have, this is problem number 132. So the probability of getting a red marble is 2/7. And the probability of getting a red or a blue marble is 2/3. All right, and the problem is, what is the probability of getting blue? Okay, so probability of blue, that's what we're trying to figure out. So think about that, see what you can come up with. All right, so what you should have noticed is we have a probability that's got that magic word or, right? And once you see that magic word or, that means you have a sum of 2 different probabilities, right? So this 2/3 is the sum of the probability of red plus probability of blue. So that means this number is added to something else in order to get 2/3. So how would we set it up in order to solve this problem? All right, so first we know that 2/7 plus something is equal to 2/3. And then we all know that we can solve this problem by using subtraction, right? So we would do 2/3 minus 2/7, and that will give us our answer. Okay, but we know that these do not have common denominators, so we need to change those to a common denominator. What is that common denominator? Right, the common denominator is 21. So we need to change these to 21. So 2/3 plus 2/7 Okay, so what is the giant 1? 7 times 3 is 21. So 2 times 3 is 6. 3 times what is 21? 7 over 7. So this is 14 out of 21. Okay, so our new problem is 2/3, which is 14 out of 21, minus 6 out of 21, and we will get 8 out of 21. Right? So this is the probability of blue. Okay. And then in this final problem, so what you're going to do is copy this spinner down. We have 1/3, 1/6, and 2/5 in the circle here. So go ahead and copy this one down. We have problem 133 towards the bottom of the page. It's okay if we go into the margin a little bit. All right, copy this down. All right, so down here we're trying to find what is this missing piece of the spinner. So go ahead and work on that and see what you can come up with. Alright, so if you had enough time to work on this, so now we know that the entire spinner is going to be 100%. So if we can take away these from 100%, we can find out what is missing. Okay, so let's first find out what's not missing. We have 2/5, 1/6, and 1/3. And we need to find out what does this add up to. Now the only way we can add them is to find a common denominator. So the common denominator between 6, 5, and 3 is 30. So we're going to put all of these over 30. And now change these using the giant one. Times 6 times 6 times 5 times 5 times 10 times 10. And so now that gives us what's not missing. Okay, so what's not missing is 12/30 plus 10/30 plus 5/30. And that gives us 22 plus 5 is 27/30. Okay, this is what's not missing. And that means what is missing, which is the part of the spinner that is unknown, is the rest of it. So if we have 27 out of 30, there's 3/30 left. So 3/30, which is 1/10. So here's the missing portion. And that's it for today's notes.